Hello, my name is Mohit Doshi, and I'll be speaking about the possibility of life on Mars. Mars is the fourth planet from the Sun and the second smallest planet in our solar system. It is a terrestrial planet, which means it has landforms similar to that of Earth. Named after the Roman god of war, ancient humans have been observing Mars since millennia now. Mars is orbited closely by two of its moons, Phobos and Deimos. Mars is a dusty landscape and is believed to be lifeless. It has a total surface area of 145 million kilometers square, dwarfed by the Earth's total surface area of 510 million kilometers square. Mars is also known as the red planet. Its surface temperature ranges from 130 Kelvin to 308 Kelvin. It has a very low surface pressure of 600 pascals, which is just 0.6% of Earth's surface pressure. It also has a very thin atmosphere and very low surface gravity, just 38% of Earth's surface gravity. This means that if you weigh 100 kilos on Earth, you weigh just 38 kilos on Mars. Mars' high carbon dioxide content and low nitrogen and oxygen content makes it a very hostile habitat for humans to thrive in. Mars' soil is basic in nature and is reddish brown due to the presence of iron oxide. Mars is also home to the largest volcano in the solar system, Olympus Mons. The Viking missions were the first probes to land on Mars. NASA's Pathfinder's Sojourner rover was the first functioning rover on Martian soil. Opportunity and Curiosity are currently the only functioning rovers on Martian soil. These rovers collect and analyze data from the soil, which tells us about a planet which hasn't changed as much as the Earth has in the past 4.5 billion years. There have also been many orbiter missions to Mars. Of these, the Indian Space and Research Organization's Mars Orbiter mission is the most recent one. The images they relay back to us tells us about the topographical features and the landforms of the Martian landscape. Mars has been a lot in the news lately. The photographical evidence of flowing water came as great news to the world. Flowing water points out to the presence of nutrients on the Martian landscape, which are essential for the growth of plants. Mars One is a non-profit organization which aims to establish the first permanent human settlement on Mars by 2025. Many space agencies around the world are planning rover missions scheduled for 2020. NASA's InSight mission is scheduled to reach Mars in 2016 and will delve deeper into the soil than any other probe before, thus unlocking the secrets of the red planet. Mars has a hostile environment, thin atmosphere, and it's virtually impossible to grow plants due to the frigid temperatures. Much of Mars' water is either locked away in the polar ice caps or underground. Mars has a magnetosphere which only covers 40% of its surface. This gives it a very thin atmosphere, which prevents it from being able to block harmful cosmic rays such as UV rays. For large-scale migration to Mars, it would be necessary to make it very habitable. One way of achieving this is to terraform the surface of Mars to make it similar to that of Earth. To do this, one theory is to crash comets and asteroids deliberately into the surface of Mars. This would increase the greenhouse gas concentration in the atmosphere, thus warming the planet. The comets and asteroids would bring valuable mineral resources such as water. By importing ammonia to Mars, we would be able to increase the nitrogen concentration in the Martian atmosphere. This is essential because 78% of the air we breathe on Earth is nitrogen. To increase oxygen content on Mars, we could use photosynthesis, which would be performed by certain microbes. To obtain power on Mars, we could use nuclear fission or solar energy. To mine resources, we could mine the moons or the nearby asteroid belt. In spite of all this, humans will face two challenges on Mars. One is the non-uniform magnetosphere, as there is no solution to that. The other one is due to the low gravity of Mars, as this will cause the demineralization of bones and muscle loss. The Earth's population is increasing by about 1.1% each year. It is estimated that the Earth's population will be 8 billion by the year 2024 and 9 billion by the year 2037. This will put an added burden on our resources. Theoretically, the Earth cannot hold more than 10 billion people. The Moon is not a good option for relocation due to an absence of its atmosphere and a high range of temperature. On the other hand, Mars is very similar to Earth. Its axis is tilted at 25 degrees compared to Earth's, which is tilted at 23.5 degrees. This means that Mars and Earth have similar seasons, only that Mars' seasons last nearly twice as long as that of Earth's. Because one Martian year is 1.88 Earth years due to its larger orbit. Even on the bright side, a Martian day is equal to 24 hours, 37 minutes, and 22 seconds, which is very easy to getting used to. Mars missions in the near future could involve sending extremophiles to the Martian surface. Extremophiles are types of microbes that not only adapt but thrive in extreme and unimaginable conditions. Some types of extremophiles include hypolids. They live underneath rocks in cold deserts. That's what Mars is. It's a cold desert. Alcanophiles. Alcanophiles thrive in any type of soil which has a pH greater than that of 9. Mars has a basic type of soil and therefore alcanophiles have a really great chance of thriving in Martian soil. Anaerobes. Anaerobes don't require oxygen to live. And Mars has very low oxygen content. Therefore, anaerobes have a very good chance of surviving on Mars. Oligotrophs. Oligotrophs are microbes that can live in nutritionally limited environments. This is very helpful as they can stay for years without any form of nutrition, even sunlight if necessary. Cryophiles. Cryophiles thrive in temperatures less than minus 15 degrees Celsius. That's what Mars' temperature generally is. So cryophiles have a really good chance of thriving on Martian surface. Xerophiles are a type of extremophiles that can live in dry and desiccating conditions. This is what the Martian surface is, and therefore they are really good candidates to send to Mars. Mars has high CO2 content and gets sufficient amount of sunlight. This means that these extremophiles can perform photosynthesis and increase the concentration of oxygen in the atmosphere. Although it may hypothetically seem possible for mass-scale Martian habitation, actually achieving this is very difficult. Currently, the most technologically advanced space crew vehicle is the Orion Multipurpose Crew Vehicle, which can carry a maximum of 6 people back and forth. The minimum distance between Earth and Mars is 54.6 million kilometers, and the maximum distance is 401 million kilometers. The average distance is 225 million kilometers. To achieve this minimum distance between Earth and Mars, Mars has to be at perihelion, that is the closest to the Sun in its orbit, and Earth has to be at its aphelion, that is at its farthest from the Sun. This type of maneuver is known as an Hohmann transfer orbit. The conditions for this maneuver occur once every 26 months. Many space agencies are currently working on mass-scale crew transportation. And besides, the process of terraforming for a planet like Mars would at least take between 5 and 7 decades.